Alright guys, let's look at lesson 10, which is intermolecular forces. Intermolecular forces, or we're going to abbreviate them as IMFs, are the weak forces of attraction between molecules in covalent compounds. So when you're looking at this HCl molecule next to this HCl molecule, there is an intermolecular attraction that is weak between these two molecules. And that is what we are going to talk about. There are different kinds of IMFs that a compound can have. So the three different main kinds that we're going to talk about are van der Waals, dipole-dipole, and hydrogen bonding. So the first, they're van der Waals. Those are the weakest IMFs. They occur between non-polar molecules, and they form temporary dipoles. So more electrons, that means a greater intermolecular force, which means a greater van der Waals forces. The key with these is they occur between non-polar molecules. So anything that is non-polar has van der Waals forces. Dipole-dipole exists between polar covalent bonds. That is because, remember, when we talked about something that is polar covalent, there is an unequal sharing of electrons. So one element in that bond is going to want electrons more than the other. So what it's going to do is it's going to take the electron density away from the other one, making it have a partial positive and a partial negative. So the partial positive end of the dipole is going to be attracted to the partial negative end of another dipole. So when we look at these two bromine chloride molecules, this is polar. Chlorine wants electrons more than bromine does. So what it's going to do is this chlorine is going to be more electronegative, and it's going to want to attract the electrons from a adjacent or another bromine chloride molecule that is next to it. So this force will increase as the bond polarity increases. So the more polar the bond, the more there will be a dipole-dipole. And then the last one is hydrogen bonding. Hydrogen bonding is the strongest intermolecular force. It only occurs between a hydrogen atom of one molecule and F, O, or N in another. Remember, H bonding is fun. Okay, so H bonding occurs with only fluorine, oxygen, and nitrogen. So only when you have a compound that has hydrogen in it and it is near another compound that has fluorine, oxygen, or nitrogen in it, you will have those hydrogen bonds. So let's look here. Water, perfect example. Water has hydrogen bonds. The O here is partially negative. The H's here are partially positive. We've seen this numerous times throughout this unit. This H is going to be attracted to this H, and here we have our hydrogen bond. So, what type of intermolecular forces will occur between the molecules of H and H? Well, I want you to think, what would an H and H molecule, H2 molecule, look like? Okay, so it would look like just two H's attached to each other. So it will have only van der Waals forces because H2 is nonpolar. What type of intermolecular force will occur between NH3? Again, think NH3. We've drawn that a couple of times. You've built it in the lab. What is that going to look like? That actually is going to be a polar molecule, but even more importantly, there's going to be hydrogen bonding because remember, we have H's bonding with N's. So this is going to have a hydrogen bonding situation. Check your understanding. What type of force exists between HF molecules? So I want you to think about this, answer this in your notes, and we will talk about this in class tomorrow.